I have worked a lot with computers and database and models, and the only thing I can tell you, I can guarantee you, they are all false. Everything we have in our database is wrong. But I personally myself consider that artificial intelligence is not artificial and not intelligent. So basically, the mines in Quebec were started, and the workers, came from Ukraine and other places, and they taught to the people here how to mine. So the point is, you don't get there because you love it. You go there because you're forced to do it. More rules, more refinements, more improvement will require more investment, and only larger companies will be able to do it.
All right. So, Pierre, you have been in the mining field for, I guess, 50 years, if I'm not
Yes.
mistaken. So, how almost 50 years? How does geology consulting and mining field change during that time?
The regulations have increased on the part of government. So therefore, there is a greater need for independent consultants. That means experts, engineers, geologists, and others other people with other professions working together to evaluate project, do feasibility studies, and so on and so forth, because it's now the law in most parts of the world, at least in Canada, Australia, in the US.
So, in terms of challenges, it got affected by regulations, but what about opportunities? And I guess technologies also developed a lot in your field. How did that change?
Yeah, well, there is more work, I think, for consultants since about 25 years, more or less, because of the regulations and the obligations on the mining companies to provide reports that are done by experts that are independent. So this is to ensure that there is no conflicts of interest, and to ultimately reduce frauds and wrongdoing. The mining industry is an industry that had the reputation, and still has some bad reputation, about frauds and wrongdoing. And the reason is mainly because mining activity is remote. I was working in the industry in the 80s and the 70s. The industry regulated itself, in the sense there was a free market at work. So the big companies who are interested sometimes in discoveries and projects realized by smaller companies, so bigger companies with more money would offer to buy projects or take them over. So they would have their own in-house experts, their own experts inside the company, who would go out and check the project and check the numbers for the estimation and evaluation of the project. So we had geologists to start with normally, and then mining engineers, and then metallurgists, and so on and so forth. And at the end, they would make a report. So the largest companies in the market would have their own internal group of experts that were doing the consulting that is done now by independent consultants inside the company. So what happened is the richest companies with the best projects, more money, would invest in that, and they would standardize. They standardize the reporting, because the mining company could not have a mine in Canada and a mine in Africa, and a ton in Africa is different than a ton in Canada, and the currencies and so on and so forth. So mining companies, when they did a report to their shareholders or to the stock market, they would have standard format for the report, technical information. So each company did that on their own. And when a company was better than the others, the people would go there, and if they leave that company, they bring with them the good practice. The big companies, they had good experts who would detect wrongdoing or fraud, or they would measure the real value of projects. But the smaller companies would be attracting frauds and criminals and so on and so forth. And that was a problem, especially when Bre-X, there were many examples, but one that really triggered the governments to jump in was Bre-X in 1996, which claimed they had found a gold mine in Indonesia. And the investment, the stock market the value of that company was $6 billion.
Mm-hmm.
And there was a struggle between large company, Barrick, and so on and so forth, to buy Bre-X. They wanted to buy it because it was such a big gold mine. And in the course of the evaluations by the big companies, they discovered the big companies were doing work that was good. And they discovered that it was a fraud. And all of a sudden, the value of Bre-X went to zero. There were traces of gold, and there was gold, small gold miners in the rivers around the area. But on that property itself, there was no gold mine, let's say. If there was anything, there were traces of gold. I know because I worked on the database, because I was, at the time, I was living in Mexico. And people were calling me from Canada and everywhere else. They wanted to know if they should buy the stock from Bre-X. Even though I didn't see the samples, I could see that the distribution of value of gold was not typical at all. It was actually typical of fraud.
Do you think, like, the fact that now there is so much technology in terms of mining industry, do you think by using this technology, it would actually detect the fraud earlier, even without regulations that we currently have from the government?
Yeah, what happens is that there is less fraud, probably, or wrongdoing, because the bar is much higher now.
What are the challenges, though, that you see on technology now? Like, obviously, it speed up the process a lot. We all know that.
So we have regulations that are more complete, define the rules. So everybody has to follow it. Otherwise, you're not following the rules. You're not complying with them. They will force you to redo your work. So companies don't want to do that. So they hire consultants and have inside their company, they train their own people to work properly, following the law and the rules of the NI 4301, Jorc, and so on and so forth, to make sure that it's okay. And then, but that makes life more miserable, more complicated. It takes a little bit more time. And every time you publish a report with an update on a resource, because you did a few drill holes, you also have to put in all the other sections about metallurgy, about the environment, about topography. And then the sections on environment and social benefits and so on and so forth is now becoming bigger and bigger. So they're telling us, they're suggesting that we should have technical reports on not more than 100 pages. Why? Because the investors who buy stock of a company in the stock market is not going to read it. He's not going to understand it if he reads it. So they want us to make short reports, but it's almost impossible. So there's a contradiction there with that. And in terms of technology, we have many softwares that do very powerful things, but sometimes they work differently. And that's a challenge for people who use the software. Now, a lot of companies, they focus on buying the cost of the software, the price of the software. But I've been saying all along, since the first day I worked with software for mining companies on a computer, the cost of the software is nothing. You could pay $1 million for the software license. Doesn't matter, because what is going to be more expensive is to pay the person who uses the software. If you hire a geologist or a mining engineer, even if it's a young one with skills, computer skills, you're going to pay him maybe $100,000 or more per year, and that will happen for 10 years, so that's $1 million. Why do you bitch about the price of the software? The software costs nothing. Buy it and shut up, because what matters is the user. Look at what you're spending. You're spending money for the user, and then you're spending millions of dollars for drilling and trucks and mining equipment and the plant, and you complain about the software that will give you all the reports and all the information you need to manage all of this. Shut up, buy the software you need and go ahead and use it. So
basically, the challenge in technologies now is that there are too many choices and people don't know how to operate in all of them.
That is one way to say it, but it's just that there's so much available that it's overwhelming sometimes for some people.
Yeah.
But in a sense, it's not bad, but it's like artificial intelligence. We think that it's going to solve a lot of problems. It's going to be useful to solve some kind of problems sometimes, but it's not going to be perfect. We're going to get mistakes, and we're going to have to make improvements. Sometimes we can improve. Sometimes we just have to live with the shortcomings for some time.
What do you think about just the role of, like, let's say, blockchain technology in mining, and like there is other emerging technologies that are currently, try to be trending, I guess, in the mining industry. Especially, like, do you think that there is net good of this technology?
The thing about blockchain is basically a tool for the police to trace. People, police or detective, people who want to know where things come from and so on and so forth, and monitor them. So there are certain applications where it's useful, like diamonds, like you mentioned, but it's a whole lot of work for all the other people who don't really need it. And I have to say that I have a prejudice against blockchain and digital monitoring of everything. I have worked a lot with computers and database and models, and the only thing I can tell you, I can guarantee you, they are all false. Everything we have in our database is wrong.
Why?
Well, look at the database with drill holes and samples, okay? You have thousands and thousands of samples. And very often they're coming from the same drill hole, okay? They're all together, one sample followed by another, okay? They're not, you can never find two samples that are identical.
Yeah.
They're all different. So what are they telling? Well, this sample is saying that the next sample is wrong. And that sample is saying that this sample is wrong. I know the truth. I am right. You're wrong. And so on and so forth. So every sample contradicts themselves. So they're all false. Because if you drill another sample or another drill hole right next to this one, you will have a series of different samples again. So the samples of reality are all different. They're all wrong. The truth is not in the samples. The truth is in the reality, which is in the ground. And the truth comes out when you mine it and put it through the plant, not through the computer, through the plant. That's when the truth comes out. And even that truth, when you sell concentrate of copper or tons of iron ore or diamonds, that's not even the truth. This is not the reality. The reality is something else than what we have in our mind, because the price we pay for these material is somebody's idea. Somebody had the idea, well, okay, I'm going to buy 10 tons of iron ore and I'm going to pay so much for it. So that's a deal. Okay, like Trump says, we make a deal. Okay, close the deal. we think the drill is a reality, but it's not. Because when the 10 tons of iron ore gets to the destination and they are used, it may turn out that they have some contamination that was not put on the bill, and so on and so forth. So the reality is something outside of our brain and our idea. So humans, we thrive and we live and we depend on mineral resources and other resources. But in the mining industry, we produce mineral resources and we depend on them and we make deals. But everything we have in our database and our computers, our computer models, they're a good approximation at best, but they're not the truth. The truth is outside and independent from us.
Do you think the tools like AI can take like this margin of error into consideration and actually improve this to make it
Yes,
more approximate to the truth?
yes, we always do. I mean, there's AI and there's other people who work with different techniques. For example, at McGill University here in Montreal, there's Roussos Dimitriopoulos, who is working on a lot with uncertainty and variance and so on and so forth. He does conditional simulation models and others to evaluate projects more accurately, and that's all fine. Artificial intelligence can help us because it's all operational research. Okay, when I was at school in the 1970s, I studied operational research. And I took a course online from Harvard University on artificial intelligence recently, and it's exactly the same thing there that I was learning in 1976. Okay, so machine learning, operational research, artificial intelligence, it's all in the same world. Now, artificial intelligence benefits from computers today that are much more powerful. So if you apply a million rules, regulations, and solve problems a million times in 1 second, as opposed to one time in 1 second in 1976, it seems so spectacular, the change, that we think, oh boy, this is great, you know. But I personally myself consider that artificial intelligence is not artificial and not intelligent. It's not artificial because it's a new generation of programming that is designed by humans. So it's not artificial, and it's not intelligent because it cannot go beyond our intelligence and our conscious.
Mm.
It's designed by humans, so it's limited by what we can give the values we can give to the program. The program is just a big machine that can go very, very fast to repeat, processes that we do slowly ourselves, humans. So we're amazed by it, but technically it's just a machine, a mechanical device. And so there are situations where it's going to be useful. If I apply technology like GPS and computers to it and blockchain and everything else, it gives you extra power. But to what extent? Well, the biggest impact, I think, will be a regeneration of interest for underground mine, because underground mining is also very old, and even the Egyptians used to dig out tunnels to make tombs for the pharaoh before they built pyramids, I believe. And the other thing is there's a very economic underground mining methods like block caving. And the fact is that the underground mining, we don't mine waste. We try to not mine waste because we don't need it. Try to focus on the grade material, and we will tend to focus on the high grade because the costs are higher, and we want to mine the material that will produce less volume, more income. So we'll go and chase the high grade to a certain point. So all that needs to be optimized. And moreover, for the danger that represents mine and underground as well as an open pit, we can have automation applied all across the board. Now, where does automation come from? Does it come from the recent technology? No. In Canada, we have uranium mines that are so rich that you cannot put a living man in the mine. In Canada, we have uranium mine that were automated from the start to the end many, many decades ago. So the thing is that these technology now can be generalized and used more extensively. In Canada, in particular, now it's becoming more and more difficult to hire people to go and work in the mines because the mines are very far from the large cities and people don't want to live there. They don't want to move there. They don't want to bring their children there. If you
Yeah.
look at the population in remote cities and towns, they are there because they had maybe they were forced to go and live in those regions, like in Siberia, in Russia, and in northern Quebec. It's not much different. How would you? Why would you go there? Well, in the 1930s, when there was the Great Depression and economic crisis, the religious leaders, the priests in the Catholic Church, mobilized the people, the population, in a large uh, parish where there was a lot of unemployment, and they organized expedition to go to the north of Quebec. So people would leave with their children and their dog and their bag of clothes, and they would move down up to northern Quebec. And what the government would do is give them land. The government gave them land. They didn't have to pay for it,
Mm-hmm.
and they could they could start agriculture. Except the only thing they could collect was rocks because they were not good land for agriculture. And then all of a sudden, people from Ukraine and Poland and other countries where they have mines came here and went to these regions, and they said, well, we have mines here, we know how to mine these stuff. And so they started to, so basically the mines in Quebec were started, and the workers, came from Ukraine and other places,
Mm-hmm.
and they taught to the people here how to mine, so people could stop hunting and fishing and go mining and so on and so forth. Not much different from gold mines in Siberia. So anyway, the point is you don't get there because you love it. You go there because you're forced to do it.
Yeah.
And therefore, the today, where people have internet and all this luxury that we have in large cities, they don't want to go and work in mines. Unfortunately, because I do. I'm one of the minority people who love actually to live in those areas, hate to live in a large city. I like it that in the morning when I wake up, I can make a coffee and go outside and drink my coffee with the birds and the mooses and the fish, and not hear one motor, not even one airplane going in the sky. And I like that.
Yeah.
So, but it's not the majority of people who prefer to
Yeah.
live like that than live in the comfort of large cities with internet and everything else.
Let's talk
So
about
technology will be helpful in the
yeah.
mining industry to be able to resolve that problem.
Let's talk about more about reporting. So there are a lot of reporting codes for mineral resource estimation.
Yeah.
Why is that?
Well, the reason is that until you get it out of the ground, you don't know for sure what you have. So and that's the first thing you do. And you do exploration, you're looking for something, a mineral that's interesting. Could be gold, it could be lithium, it could be whatever it is. And once you find something, you need to report it. If you want to be financed, you can do it privately or publicly. If you go public, then you need to follow certain rules so that the people who will lend you money, will buy your shares, are not, going to lose all their money. The thing is that the stock market is not the government. The stock market is a private enterprise. It's an exchange where people can trade shares. The shares have a financial value. So it's to bring capital into the stock market to finance projects like mining projects. And the stock market does not want criminals to go on the stock market to sell shares of projects that don't exist. So they require experts, technical experts, to evaluate the project. And to be able to understand each other, everybody has to use the same language, the same technical terms, the same rules. So they institute that into in our case here in Canada, it's the Canadian Institute of Mine and Metallurgy that set up committee. Committee is a group of experts that will work on defining the rules, what rules we should apply, how many drill holes, how many samples, how should we take the samples, how we should calculate the resource, the volume and the tonnage and how much metal there is. Now, Canadian Institute of Mine does the technical part. The stock market will supervise the application of those rules. So they have a committee in the stock market with experts, technical experts who understand the rules, and will make sure that every statement, every report is complied with those rules. But for the whole thing to work, the government has to come in and make a law. So in Canada, like elsewhere, the government will step in, will take a look at the rules, the technical rules defined by the CIM, and look at the stock market requirements for safe investment, and look at the economic law in general, and write a law. So lawyers will write the law and say in the law what should be done or not. But it cannot be the same as technical rules defined by CIM, because the law applies to everybody and everything. The CIM will look at specific problems of diamond industry, coal industry, so on and so forth, to define the specificity. So the law basically will say you have to do this and this and that. And beyond that, you have to apply the rules recommended by the CIM. The CIM will have committees that work on resolving problems and improving the rules all the time. So that progress or moves independent of the law, which is managed by the government. And the stock market, they have the authority and committee to supervise the application of the law and the rules to the specific companies listed on the stock exchange.
Why NI 43 is kind of like more popular?
Okay, the reason why it's more popular is simple. The US have the SEC rules, okay, and they're very strict. Okay, you cannot have inferred resources in the report. There's very strict restrictions in the US. And investors in mining didn't find that justified. And they found that the rules in Canada were more suitable for the mining. Okay, so in other words, if you compare the rules and regulations of the stock market in the US and in Canada, Canada allows for a little bit more room in speculation, okay? So investors who look at the mining market a little bit like buying a ticket of lottery, were more comfortable with that. Now, Australia is very similar to what we have in Canada in terms of rules, regulations for the stock market. London is very important. So those are the markets where mining companies could find investment. Canada, Australia, London, New York. London and New York are very similar. London and New York stock market are usually typically, historically, for the large companies, very, very large companies. And they have strict rules that does not allow many technical statements that is allowed in Canada and Australia. So the large companies that have income from large mines, they are comfortable to sit in the stock market in New York and in London. So this is how the financial market for mining was split, and it still is split today. So companies that have mines in Peru and Africa, everywhere, come to these stock market. New York and London, if you have a big mine, a big mining company. In Australia and Canada, if you have a smaller mine, junior mining, and so on and so forth. And there was a point when the NI 43-101 was instituted, was uh, imposed, if you wish, or whatever,
Mhm.
that Canada, I was told, I don't know, I don't have the numbers and I didn't check it out, but I was told that 60 to 70% of the mining capital came from Canadian stock market. Okay, so Canada was making a significant contribution to finance junior mining companies. Okay, so the NI 43-101 became very important just because of that.
Yeah.
If your money for your project in Africa or in Peru or in Chile or Argentina is coming from Canada, Canadian stock market, it could be a Russian or a German or a Italian investor buying shares of a gold mine in Africa. But if the company is listed in Canada, it has to obey to the stock market rules in Canada, and that's NI 43-101. So that's the reason. It's not because Canadians are smart or have more minds than other countries. It's now the problem here. Here's the thing, okay, about Canada. With the so much capital and investment going through the stock market in Canada, applying the law from Canada,
Mhm.
this is generating a lot of work for Canadian consultants. Geologists and mining engineers and metallurgists in Canada are getting a lot of work for expertise on investment in mining all over the world because the
Mhm.
capital comes from outside of Canada and comes into Canada and then goes out of Canada to the mining project. And the expertise is located in Canada for the stock market exchange, for the consulting work. So this is benefit for Canada. Not it does not mean that we are so smart or big on mining in Canada.
Jorc now updated their its regulation a little bit by emphasizing more like ESG factors. Do you think it's kind of like tries to be more similar to NI 43?
I don't know because I didn't study the changes in the Jorc yet. Okay, all I can
Mm-hmm.
tell you is Jorc. Usually, Jorc is very close to 43-101, but not quite as.
Yeah.
For example, 43 NI 43-101 requires, it's an obligation if a mining company drills a project and there's a material change. Let's say they didn't have resources, now they have resources. Or they had resources and the resources double in size. Or they
Mm-hmm.
go, or the work they've done this year allows them to make a feasibility study.
Yeah.
Then the stock market says if you have that news, then you have to prove it with a technical report that needs to be published and made available to the public. The Jorc did not require that. The Jorc follow the same rules and so on and so forth, but the companies in in Australia did not have the obligation to always publish a technical report. They could talk about it, they could do it,
Mm-hmm.
but they didn't have the obligation to publish it. There's other small differences. For example, in the Jorc report, you can have you can add the inferred resources with the indicated in the NI 43-101. You cannot consider you cannot present your inferred resources with the indicated. They have to be separate, so on and so forth.
Mm-hmm.
And then NI 43-101 tends to lead to be ahead of Jorc when it comes to NI 43-101 is improved all the time. So when the environment becomes important, we say, well, you have to have a chapter that explains what the impact on the environment will be from your project. And then it becomes more explicit telling us
Mm-hmm.
what we must explain about the environment.
Yeah.
And then the ESG is the same story. So you have to calculate the carbon footprint of your project, and you have to explain what it is. It doesn't mean that you can't do it, it says that technically you need to explain what impact is on the environment, what are the social economic consequences
Mm-hmm.
are, so on and so forth. And in Canada, for example, right now, it's much more complicated to get a permit. You need to consult the public much more than before, and so on and so forth. Well, there are differences between the different regulations, and there are uh, always an effort to make them similar. There's the
Yeah.
Crisco, and other initiative taken by the United Nations or whoever to bring the regulations together and to be the same.
How much detail should be included in the disclosure of reservoir prospects for economic extraction in relation to like initial assessment,
Well, what you have
where
to
like
do,
a yeah.
basically, the PEA requires that you complete your resource estimate. The description of geology is always there. And when you get into after the resource, you start to have information about mining. So PEA level is a comparative study. So you'll say, well, we have this project, we have this resources. That's a known fact. If we compare it to a project that is similar, they have this kind of a mining method, this kind of mining equipment. We think we could have something similar. So you take technical information from another project similar to your mineral resources, and you say, if we apply those factors to our project, this is what it would look like. So you don't complete the detailed study to apply it to your project. You borrow information, technical information for mining and processing from other similar projects to say, well, we compared to this other project. Now, if we use the same process, the same mining method, this is the value of the project. So that's a PEA in a nutshell.
Mm-hmm. How like with these different reportings, right? Like there are different updates. What do you think will be the future of mining reporting and practices?
There will be improvements and changes. Things will get more complicated, perhaps in a way, and require more expertise, more people. And the paradox is that the bigger companies will be able to do it more than the smaller companies. So therefore, there will be more bigger companies and less smaller companies. Now, I'm not sure how that will pan out in terms of capital investment and whatnot.
Mm-hmm.
But the logic is that more rules, more refinements, more improvement will require more investment, and only larger companies will be able to do it. And the larger companies will have more ease to apply those, and the smaller companies, it will become more and more difficult. Now, the solution that use the small companies right now is they have a shell in the stock market, they have investors, and they do everything by consulting, or the
Yeah.
most of their work is done by consulting. Regulations will, will have the effect of reducing the number of small companies relative to the large companies. It doesn't mean the number will reduce itself, absolutely. It's relative to. In other words, there will be more capital invested in larger companies, fewer larger companies, and relatively less capital invested in relatively small companies. But the number of small companies could increase. It's just the way the money is going to be distributed is going to be different. Just like the rules and regulations are designed to stop fraud and malpractice and whatnot, it reduces the cases where people make mistakes or crimes with the stock market, but it does not eliminate it. That's one of my specialty in my work. I did a lot of cases of investigation, so I know something about that.
You've been a part of kind of like many companies, and a lot of exploration companies, they don't make it to their production point for various reasons. And usually one of the reasons is that they can't secure financing, but a lot of other mistakes can be actually mistakes in management. Do you see it like in your practice a lot? Do you see that?
Yes, but it's a little bit more complicated than that. For example, I can give you examples that some companies have good project, good management, good finance, and they continue to grow and develop projects. And they go from small projects to medium sized to large projects. So it's a progression that is normal. And as they grow, they hire more people and they become better.
Mm,
But the economy goes into cycles. And when the economy goes down, the the product of that good company may not be in demand, and the price falls, and they get squeezed. Okay, they get caught.
mm,
So the work they've done is good, but it's not what you need for the moment because the economy has turned around on you. So you can enter into difficulties. So you have to make choices. And what I've lived through, I work with different companies that go through these cycles. And when the situation gets worse, in mining, usually it gets very worse very fast. And the company that survive are the ones who see that coming and decide to take their best asset and sell it. And that's heartbreaking. You can see a company going well, having a team that is very efficient, developing very good work habit, and you have a corporate culture. You see, like inside that group, there's a unity between the members, the engineers, the geologists, the managers,
mm.
and they become very efficient. Like it's like people start to act like without talking. You just know what you need to do, and you go and do it. So you have very good synergy and so on and so forth. But all of a sudden, the market turns back on you, and you have to let go something to survive. And those companies who succeed to survive are taking their best asset and selling it to get rid of it, sell it to a bigger
As it
company. What a company that had over 10 mines, okay,
mm,
copper, gold, so on and so forth. And when they went through a cycle like this, they took the best gold mine they had. Okay,
mm.
of all the mines they had, it was a gold mine with very good output, very good income, very high grade, and they just dump it on the market because you see the economy is getting bad, and investors are running away from mining. So how can you get some cash flow to survive? You have to take your best asset and sell it. It's like a mother with 6 children or 8 children, and you're going through a bad economy and you can't feed them. What do? Well, you take your oldest son and you tell him, okay, goodbye. You have to leave the home. You have to go and work in the mining field and send us some cash. It's heartbreaking because you have to let go of your best asset. That's the only way to survive when there's war or crisis, economic crisis.
And many experts warn about like depletion of easily accessible mineral resources. What do you think are biggest challenges in discovering and developing new deposits, and how does it affect like project feasibility?
All the gold, all the iron, all the aluminum, the nickel, the lithium, all the oil that we use since the beginning of humanity. Okay, everything we have found, used, burned, twist, melted, give it shape and forms, cars, telephone, television, all of those things. Okay, where are they today? They're right here on Earth. When we're finished with this stuff, we don't ship it to Mars. We don't send it to Venus. We don't send it on the sun. We don't dump, well, most of them we don't dump in the sea. But even if we dump it in the sea, it does not disappear. It stays in the environment. More specifically, we dig those materials from the biosphere, not even deep, just the biosphere, and it stays in the biosphere. All the oil and the coal that we burn goes into the atmosphere. It barely rises the CO2 if it does, because volcanoes do it more efficiently than humans can produce CO2. And it goes in the sea water, and then it's taken by the biomass, transformed into algae and fishes. So the carbon cycle goes right around into the biosphere. And all the metals is the same. You know, every once in a while, somebody says the waste dumps of the municipal waste dumps of large cities is the mining of the future. It's just more expensive. It may be more expensive to extract lithium from a cell phone dump than to mine it. Okay, so until that happens, we'll continue to mine for fresh raw material, aluminum, lithium, nickel, and so on and so forth. And if that becomes more expensive than mining the dumps, then we will mine the dumps and recycle. And if we don't do it because of the nuclear war or whatever you want, okay, nature will take care of it, because in nature everything is recycled. The problem with oil is it takes so long to wait for the CO2 to come back in the form of oil that we prefer to grow corn in the field and take the corn to make oil that we can use for fuel for our cars. So everything is a question of economy and this. But natural resources, they're almost infinite. There's been discussion, there's a very predominant notion today that there's too many people for the resources we have on Earth. No, yeah. It's the opposite. We have the resources that the people can produce. Humanity is adaptable. We adapt ourselves by producing what we need. And yes, the best mines with the higher grade, the lowest costs, are now gone, okay? But we still find some new projects with very high grade material. They're just not, in locations that we thought about. But we continue to make discoveries. There's still oil being discovered, all kinds of all around Africa right now on the coastline, and so on and so forth. And this is true for all natural resources, And we could talk about agriculture, because that's the other side of the same theory, ideology, I should call it, that we have too many people, we're going to run out of food. No, we don't run out of food. We make our food. The more people we have, the more food we produce. This is ridiculous. Humanity is nothing. If we take 7 or 8 billion people that live today, and you put them standing one by one, side by side, okay, and we leave them room for arm's length to be able to breathe and move around, how much superficie we occupy? We won't fill the Manhattan Island in New York.
Yeah. I've seen this statistic that if you put
So
like
I mean, this is what I think. So all to the people who say that we're too many people, we need to kill some, or I don't know what. It's nonsense, you know. The same thing for wars. I mean, why are we so destructive? I can't believe it. It's the same kind of people who say that we are running out of resources, that we have too many peoples, that we're going to starve to death, who are organizing the wars. And those people should be put in jail. That's all I have to say about that.
I think we can finish on this optimistic note.
Yeah.
Well, thank you so much, Pierre. Thank you so much for your time, and I look forward to maybe do it again sometime.
Okay. Thank you.
Thank you. Have a good one.